Here we have a spreadsheet where we're going to look at different investment options. We have different amounts that we can invest every month, and for planning purposes, we can plan on different rates of return. We can't control how much return that we're going to get, so we might want to see a range of values that we might get at our different investment levels. Okay, so we have all the calculations here for us. So we have a one-time investment of $5,000. We're going to invest potentially $100 a month for 40 years, working from age 25 to 65, let's say. And with an expected return of 9%, that would give us $648,682. But let's say we're thinking about investing more than $100 a month. We can look at the different ways that increasing our investment and changing the return could affect this future value. So this future value is what we really care about. So we're going to create a cell reference to that future value at the top left of our two-way data table. I think it looks a little bit weird just to have that number kind of at the top left of our table, but Excel needs it, so we've got no way around it. Then I'm going to select the first row of values and that column of values. The biggest mistake people make when creating data tables that I've seen is that you want to copy or include these header cells, the expected return and monthly investment. This is going to mess up your data table calculations. It's just not going to work. We only want to select the values that we care about. None of those headers. So then I'm going to go to Data, What If Analysis, Data Table. So the row input cell, so I've got my model inputs in column B in that top section under changeable inputs. So here across the top row, I've got my expected return. So I'm going to essentially inject this expected return, this row, into my spreadsheet here, cell B7. The column input cell, that's how much we want to invest every month, and we find that in cell B5. So basically what Microsoft Excel is going to do, it's going to take each one of these expected returns with every combination of monthly investment, and it's going to inject them into these two different values here and determine the outcome of our future value. So I click OK here. Microsoft Excel very quickly calculates the result for us. It's not formatted super nice, so let's fix that. I'm going to choose number, but I'm going to get rid of the decimal places because I don't really want the decimal places. Now let's take a look at what this means. So with the 9% interest rate, $100 a month, I'm going to end up with $650,000, more or less. If the interest rate, if I don't get a very good interest rate, I have, almost half as much money. That 2% interest difference between 7% and 9% makes a huge difference over time. So one thing, if you're planning for retirement or investing, you might want to be a little bit pessimistic. This 7%, we could say maybe is the worst case scenario, hopefully is the worst case scenario, because I do plan to retire someday. If the return is better, fantastic. But you want to be somewhat conservative planning for your retirement. You want to enjoy your retirement. So let's look at what happens if we start investing more money per month. Things get really nice. 40 years, if you can invest $500 a month and you can get a 9% return, again with a $5,000 initial investment, things are going to look pretty good. You're going to be a multimillionaire. That just is what it is. And if the stock market does really well, you're going to have more millions of dollars. If the stock market does pretty bad, you're still going to have $1 million at 7%. Now, if you can put away more money, obviously you're going to make more money over the long haul. But of course, you don't want to sacrifice your entire life to save for living in the future. So clearly there's a balance. But there's a big difference here. So we've got a big range of values. We've got Microsoft Excel with this two-way data table just calculated, do the math, we got 1, 2, 3, 4, 5, 6 columns and 20 rows. So we're just very quickly able to look at 120 different scenarios, isolating changes with those two variables. So pick which one you want. How much money do you want to have if you're going to work 40 years and retire?